And we are live. Welcome, everyone. Hugo Bown-Anderson here from Coiled, but more importantly, Dr. Jim Bednar from Anaconda. Hey, Jim.
Hello.
How are you?
Pretty good. Thanks for inviting me.
Thank you so much for joining us here today. It seems like I have a lag in my video again. So what I'm going to do is quickly shift cameras. I won't look quite as pretty, but there'll be less lag. And there we go. So thank you all for joining our Science Thursday. Of course, for me, it's Science Friday because I'm on the other side of the world and we walk upside down here. So it's Friday morning in Sydney, Australia. For all of you joining, if you wouldn't mind introducing yourself in the YouTube chat, and letting us know who you are, where you're watching from, your interests, that would be really, really cool. But I'm really excited because what we're here to talk about today is Datashader, right, Jim? Yep. And being able to plot all types of incredibly large data sets and kind of extract, insights and value from your data using at-scale visualization.
That's right.
So maybe before we jump into that, by way of introduction, you can tell us a bit about yourself.
So I work for Anaconda right now in Austin, Texas. I've been working on Python open source library since 2003. We're still using the param library we created. And in 2015, I came to Anaconda. I decided to move back to the USA. I was at University of Edinburgh as a professor in Scotland working on computational neuroscience. But at the time, I was noticing we were spending all our time fighting with tools. We need to have better tools before we could do our research. And then by the time we're done with our research, our tools, there's no time for research. So I figured we ought to line up our incentives and get paid for doing tools instead of getting not paid to do tools. So moved to Anaconda, and really I've never looked back. I ended up hiring a good portion of my old research group, reconstituted it inside of Anaconda, and now we work with Anaconda's government clients and researchers and corporate clients, and basically they tell us what they need better about the tool, and we make the tool better and then give it to everyone for free.
Awesome. And you raised many interesting points in there. One that I want to just zoom in on quickly is that you were working in research and you needed better tools. And I think this is something that we talk about somewhat, but maybe not enough, is that a lot of the PyData and SciPy tools have been developed originally by practitioners who really need them, right? And that's one of the reasons that they've been so practical and solved a lot of problems and gained so much adoption, right?
Yeah, they're zeroing in exactly what the need is. It may not be the 100% best solution, but it is a solution to the right problem.
Yeah,
that is, it's going to be a solution to the right problem. So
yeah,
it wins every time.
This is great. Already we've got people rolling in from Pittsburgh, from India, from Sweden, interested in data visualization, which is really cool. While a few more people join, I told you this before we started going live, Jim, but I started using the IPython notebook in 2012 or something like that when I was working in cell biology in Germany, and then I moved to the US. And there were all these like PyData events and that type of stuff that started happening. And the first Python meetup I ever went to in New York was organized by then Continuum Analytics, now Anaconda. And one of the people who spoke was an electric individual who I'd never seen before, who was Peter Wang, who is now, co-founder and now CEO of Anaconda. And he gave a talk on Datashader. And I think in equal measures, I was amazed by the technology and also just amazed by Peter's energy. But it's funny, things come full circle, right? That the first time I ever really encountered the PyData community was a Datashader talk, which I loved a great deal.
Very cool. Yeah. So Peter Wang was the original driver behind Datashader. He didn't code it, but he lined up government agencies interested in funding it. He pitched the idea. He coordinated people, and the day I showed up at Anaconda, he sat me down and said, "Okay, you're in charge of Datashader." I'm in charge of what? I'd never heard of any of it. He drew a bunch of equations on a whiteboard, and I said, "Nobody's going to want that." But okay, if you tell me, oh yeah, okay, I'll do that. And then the more I got into it, the deeper into it, it became very clear that it was an amazing thing, and that Peter had been prescient, really understood what the world needed. in this particular corner of the world, and it's really cool.
Awesome. So maybe we can jump in. I know the first thing you're going to do is show us the Datashader landing page, and I'm going to share that in the YouTube chat so people can check it out as well. But yeah, if you want to jump in, share your screen, and we can dive into this wonderful technology.
All right. So yeah, so this is going to be highly informal. So please raise questions, and Hugo can interrupt me, and because I'm just going to sit here showing off cool stuff. So we can chat about anything during this.
Fantastic.
At the beginning, I'll just try to make it clear what Datashader is and why you need it. So starting with datashader.org, it has a user manual. I'm not really going to cover any of that. That's dives down into a lot of the weeds. I'm going to try to stick to the main points. But if you go to the website, you'll see a couple of things. One is that it's got very pretty pictures. These are all the source code for all of these. You can follow it and generate all these pictures yourself. And the other thing is that
they're gorgeous. And were they generated by the team or by users as well? And
well, that was what I was about to say. These particular ones, I did these three. So that was me. But
awesome.
Over here under the Twitter feed, you see what the rest of the world is doing. There are lots of people on the team who are not me, but I just happened to generate these three. But if you look at the Twitter feed, you'll see what the rest of the world is doing. This is one that just appeared. Apparently, this is a mathematical phenomenon where a bunch of data points form the thing that looks like a comet. I didn't know it about it before it, but saw that Datashader was using it. If I scroll down, there's some others that the Datashader itself put out as a project, but then there's apparently, I think this is the Ukraine. It is using data to understand aviation traffic patterns.
And the other thing to note, of course, is that you know, a lot of these tweets include references to Bokeh or HoloViz, and we'll get to that, right? But that's one of the beautiful things about the ecosystem, right? Is that it's a kind of a set of interoperable tools that work really well together.
That's right. So I'll skip ahead just to that. So as a group, my group in Anaconda is called the HoloViz group, and we came up with that after we made all of these libraries down here, including Datashader. Datashader is one of several libraries. And we realized that the rest of the world has no idea these are related. Like some of them have similar looking icons, but really there wasn't anything to hold them together. So we created this organization called HoloViz. We briefly called it PyViz, and it confused everybody. So we stopped doing that because they thought it was all of Python data visualization. It was never that. It was whatever we were working on. So we renamed our stuff to HoloViz. And so we'll talk about a lot of these tools here. Bokeh is not part of HoloViz, but a lot of the tools here build on Bokeh. And so there's Datashader as a standalone library, and I'll show you what you can do with Datashader itself. And then everything else is Datashader embedded in some other project, some other library. So this particular one, this is somebody who used Datashader all by itself to render an image. But then you can find other people. This is one who's embedded Datashader. I don't know what that is, but cell phone towers. They use Datashader embedded in Bokeh to create an image of cell phone towers.
Great.
So basically, it's worth scrolling through. You can just see what the world is doing with Datashader, which generally is making very striking pictures I do not understand. Because I don't have their data sets often. I see the pictures. In this case, it looks like a plot of school locations. And I'd have to translate that to be sure, and so on.
So everyone, if you're on Twitter, follow Datashader for lots of cool data visualizations, if nothing else, to just make your Twitter feed more visually appealing.
Pretty, yeah.
In terms of the other packages as well, we probably have a few people joining. I can see one, but I'm sure we have several others who are X-Array insiders.
Yeah. All right, so I'll try to give a brief putting it in that context. So Datashader, when it was first written, the core of it was written by Jim Christ. And what he used was a triumvirate of super important things. Well, first NumPy, because everything uses NumPy. So we don't even ever say the word NumPy.
Yeah.
But it's based on X-Array, Dask, and Numba. And all three of these are super important. And basically, we use Numba to be able to write Python code and have it run as fast as the hardware can run. So it compiles it down to raw machine code, and we run anything you do in Datashader will be accelerated to raw machine code. There's no interpreter. There's no reading a Python string and parsing it or anything like that. It's just raw code, the same as if C or Fortran. So we use Numba for that. The data structures involved are, I'll show about what it is, but basically it's using X-array. So the output of Datashader is always an X-array. So it's an X-array, which is basically a wraparound NumPy array that's been annotated with what those coordinates are.
Mm.
And then it's using Dask so that we can make, basically, so we can soak up all compute resources in the vicinity. We can use all the cores on the machine. We can use all the machines in the room, all the machines in the cloud computing center, all the cores on the supercomputer, whatever it is. You can use Dask to distribute the work out to all those workers, run it, and then collect the results and display it. So those are the things that it's built on, and that's what makes it fast, and that's what makes any of this work.
Awesome. That's a wonderful introduction to the ecosystem. And it's heartening to hear how many tools are working synchronously there.
Yeah, that's the top level of them. Like I said, it goes, there are many tools down under there.
Awesome. So let's jump in. What do you want to show us?
All right, so I'll first show you, so that's datashader.org, and if you go to the user guide, datashader.org will tell you all about how to use Datashader by itself, and a little bit of how to use it in other ways. I'm also going to show you a bunch of examples of Datashader. You can get the complete source code in rerunnable projects at examples.pybiz.org. So anything that I show over here, pretty much all of them are going to be on this page, and they'll say Datashader on them. So this,
and I'm going to share that examples.pyviz.org in the chat as well.
Yeah, and actually out of the first 8 or so, one of them doesn't use Datashader, the rest do. Because we pretty much just thrown at everything. Wow! And it's exciting, and we find out the cool stuff we didn't know before. So a lot of times we didn't plan to write an example on Datashader, we did it, and then afterwards we say, okay, that's pretty cool, we're going to throw that in. So you can find all the examples there. And then what I'm going to do is basically work through a tiny little bit of this tutorial that's at holoviz.org. HoloViz tells you how to use all these tools together. And I've adapted the first plotting tutorial very slightly for the purpose of this talk. So it's basically what you see online. The only thing I did is change it to use Dask in this example just to show you how to use Dask. But the default one online uses pandas. A month ago it used Dask. We need to figure out how to make it have a little button at the top that you switch. Show me the Dask example, because you can do the same thing on pandas data frame, a Dask data frame, a CuPy data frame, a CuPy data array, a cuDF, all sorts of things, depending on whether you want to use clusters or whether you want to use GPUs or both.
Yeah, and I just want to kind of tease out something hidden in what you just said. The fact that you could kind of switch out pandas data frames for Dask data frames relatively easily in the notebook speaks to the fact that the API is incredibly consistent. And Matt Rocklin always says that, you know, one of the things they tried to do with Dask was to invent as little as possible, right? So
yeah, and that almost works. Basically, inside of Datashader, there's Jim Chris was the one who coded this all up originally. He put in multi-dispatch for the things that Datashader does, and so it dispatches to different code for pandas and for Dask and for CUDA. But the code is quite similar, and a lot of it is shared. And so from the point of view of the Datashader user, just feed us whatever you've got. If you've got a pandas data frame, feed us that. If you've got a Dask data frame, feed us that. cuDF, feed us that. And then internally, we take different code paths, but it's largely the same thing. And so, yes, ideally, if the world could work together and have it actually be the same thing, we could collapse all of those code paths onto one code path. Inside of Datashader, they are not one code path in most cases. Yeah,
okay. And there are a few things like you've got a .persist here, and you may need a .compute somewhere else.
That's exactly right. So to make this work compared to what was on the website, you change, instead of pandas, you import Dask data frame, and then there's .persist. Occasionally there's a .compute, but I don't think that even comes up here.
Yeah, and I also love that you're reading a Parquet file, which I think should definitely become more standard. Matthew Powers, who works at Coiled, is currently writing a blog post on, you know, why you should use Parquet and why we should, well, not quite, but why we deprecate CSVs, essentially.
Yeah, basically, do you consider your time important? If so, use Parquet, for God's sake. Take your CSV file, process it for 15 minutes, create a Parquet file, and then everything out of that after that is 5 seconds. So yeah, it's a very good match to Datashader, because if not, you're going to be spending all of your time parsing that CSV file. So
Yep.
utter waste of your life. So yes, put your data in a sensible format. And Parquet is a sensible format for columnar data. ZAR is a sensible format for gridded data.
Exactly. And so if we want to go slightly one level deeper, a really good advantage of Parquet is that you can prune columns before importing, right? So you don't need to read everything like you do with a CSV before choosing what you want to look at.
That's exactly right, and it's and you can even read only parts of the file and only a certain range of rows if that's all you needed. Although in this case we just always plot everything. So
yeah, absolutely. And the other thing, of course, is Parquet's clever with metadata. The amount of CSVs that have incorrect columns and all of this stuff, or no metadata, actually, right?
Yeah, generally a CSV file is an exploration project. In a Parquet file, you can just start to work with and get your job done. Yeah. So any of these examples you'll see on the website, we either assume it's already in Parquet or we show you how to make it into Parquet. Otherwise, it's really, because you can always do it once or twice, but when we're doing these things, we run these examples every month or so, several times. And whenever we're doing a talk, we'll run it like 50 times. We totally don't want to run, because our stuff is done in this amount of time, but the CSV takes that much time. So
totally. Yeah, I hope our audience is here for data visualization, and we're talking about file formats. Hopefully they're as excited as we are about it. I'm sure they are. But yeah.
Okay, so we're going to not talk about file formats anymore. We're just going to say that we got a file into a pandas data frame, and this particular file happens to have a good number of columns. Like you said, you could have just not even, you could have discarded almost all of those and it would have saved some reading time. But let's say we have this data frame, and let's just, and actually I'm going to make there's a large version and a small version, and you'll see why in a minute. The small version is 1% of the data, and the large version is 2 million rows, hang on.
Just quickly, before we go on, we do have a question. Can we point to an example of moving CSV to Parquet that you just mentioned? So we do have significant interest in.
Yeah, I'm sure if you do site examples, pyviz.org, CSV Parquet, something will come up, but I don't have it off the top of my head.
Okay, just say that one more time. I'm going to have a quick search while you continue and share it.
If you do a Google search and restrict it to pyviz.org or holoviz.org, and then for CSV and Parquet.
Right.
But really, it's just read CSV and write Parquet.
Yeah.
Simple as that.
Right. All right.
All right. So anyway, so so basically we have this data frame, and you can take the data frame and plot. I really ought to figure out how long this is. So hang on. Unfortunately, that requires loading it in. So it's 2 million rows. Okay, so this happens to be a plot of earthquakes. And let's say you use the default plotting. This is a Matplotlib based plot. We do a scatter plot of the longitude column versus the latitude column. And we're using 1% of the data, because if we didn't, it would take a long time. And so we get a plot like this. This is the kind of standard visualization issue. Plot something against something, and this particular one happens to be in geographic, like real world coordinates, so you could actually see what it means. This is Alaska, for instance, and this is South America, and this is the Pacific coast, and I'm over here at the moment in Austin, Texas. I can see that, but probably a lot of people wouldn't see that immediately in this collection of dots.
I wouldn't.
So yeah, you need to be guided through it to see that, and that's because it's such a tiny fraction of the overall data. But what if we take what if we use Datashader for this? And here I'll break to these points apart in a minute, but here's a dump from Datashader with no parameters. The only parameter is how big do you want your plot and what colors. I chose white to black. And in this case, this is all 2 million earthquake events that happen to be in this data set. And here you can see pretty much what's going on. You can see a lot of the structure of the Earth from merely the fact that there has been an earthquake located at that particular point. So what is this plot of? This is the plot, and what is it? This is the PNG. Datashader, Datashader as a standalone library, the best it can do is give you either an X-array or a PNG. That's all it does. It doesn't know anything about axes, about interactivity, about labels, legends. It knows about none of that. It is a core number crunching part internal to a plotting library, or that you can use on your own, and then it's up to you to know what you're doing. So here's just the raw output, and what it's done here is give you a 700 pixel wide by 400 pixel tall array, and it's going to color the pixels in that array ranging from white to black depending on how many earthquake events landed in that pixel. So in this pixel, 0 landed, so it's white. In some other pixels, quite a number of earthquake events landed. You can't tell because there's no hover, there's no interactivity. There's just this raw dump. But basically, every pixel is colored by how many earthquake events landed in that pixel. And it's just taking this latitude and longitude data and dumping all of it, all 2 million rows of it, into a fixed size grid. That's called rasterization. It's also 2D histogram. That's, in this particular case, you can think of it as a normal 2-dimensional histogram where latitude is along the y-axis and longitude is along the x-axis. That make sense so far?
Yeah, it makes perfect sense. And it is pretty cool that, as you mentioned, without providing any parameters or quags or anything like that, it renders something like this immediately. So you get, at least some sort of insight into what's happening. That's pretty cool.
That's a meta message I will keep returning to, is that use Datashader to reveal to you the structure of your raw data. Don't do any processing before it. Get the rawest possible form with as many data points as you want. Normally people will subsample it, they'll average it, they'll select, they'll zoom down to a tiny bit of the data just because that's what's practical in a plotting program. But don't do that with Datashader. Dump the whole thing, uncorrected, untransformed, just dump it all from the start, and I'll show you why in a minute.
And you've been able to do it in 3 lines of code and an import as well, which...
yeah, in this case, it's 3 lines of code. We'll get to the 1-line version in a minute, but also...
Okay, so I was impressed with 3, so the fact that we're getting to a 1-line version is,
Yeah. So this is Datashader's native API, and I'll briefly step through that, and then I'll tell you never to use it again. Cool. So Datashader's native API creates a canvas with a certain plot size. This is basically an empty object that you can draw stuff in. And then it says, I want to do a points plot. Now, Datashader supports lots of kinds of plots. Let's see, there are points plots, regridding already gridded data. There's triangular meshes. There's plotting network graphs. And we're missing one for polygons. It also plots polygons. It's totally missing from the user guide. That'll be a theme too. Anyway, so we're telling it to plot points for this data structure, and this is what goes on X, and this is what goes on Y. And then this, if you just stop there and just look at ag, ag is an X array. So what it's done is turn, so if you've executed this, in fact, let's just put time on there. So if you execute that in 500 milliseconds, it iterated through 2 million data points, created this X-array, which is a 32-bit integer array, and each of the values is either 0 if there were no earthquake events in that pixel, or a number. And I'm sure there's a way to show your X-array range, but there's some some of the pixels are not empty. So this is what you get out of, this is the key core part of Datashader. It turns your data into an X-array raster. And then, but you can't see an X-array raster, it just looks like some numbers. So then you can do what's called shading, and shading maps this color range, those numerical values onto this color range.
Awesome. And for those who haven't seen X-ray before, when we saw the output of the X-ray, you could see like the coordinate axes and that type of stuff, which is one of the really cool things about X-ray.
Yeah, compared to a NumPy array, an X-array has a lot more metadata. It knows that X is not just X, or it's not just R's and C's, rows and columns. It's latitude and longitude, and it knows the mapping between the first index is actually negative 179 in longitude, and so on. So it knows how it's got enough metadata about it to be able to treat it scientifically instead of just as raw computer science rows and columns.
For sure.
All right, so that's the core thing that Datashader does, but the only thing that you can do with this thing you got back is you can drag it around. You can cut it and paste it. You can put it in a PowerPoint. You can make a tweet of it. That's great. But let's do a little bit more here. Here's the one-line array, which is the one-line version that I would recommend you do instead, which is import hbplot.dask, because I think that's a Dask array here, df. And then you have the same way you can use .plot, you can use .hbplot. And the reason you want to use .hbplot is it has this nice function, this nice option here. hbplot is the same as pandas.plotting and xarrays.plot, but it's based on HoloViews, which in turn is based on Bokeh. And then it gives you, in fact, hbplot could give you a standard looking plot, like with a tiny amount of data and hovering and all that. But here we're going to use it to give a rasterized data shaded plot. And so to do that, we just pass this flag to hbplot and says, don't pass the data down into Bokeh. First, rasterize it and pass the result of rasterizing down into Bokeh. And why is that important? Well, imagine that you've got a supercomputer somewhere with 1,000 CPUs crunching all your data. Each one of them has a little chunk of your data. Each one is calculating a little bit of it. If you took all of that data and tried to pump it into your web browser, Bokeh would crash, your web browser would crash, Chrome would crash, everything bad would happen. Instead, what's going to happen is if you've run it on a server, all of that crunching is going to happen on the server, and you send in each of the different nodes will compute the same fixed size grid, and then it'll combine all those fixed size grids into one fixed size grid, and then that's what you display.
Awesome.
So what's happening here with this one little call here is that you've turned from client-side rendering to server-side rendering, and server-side rendering using Datashader can handle as big as your server is. It doesn't matter how big your cluster is or what it's on. It's going to use those computing resources and then pass you the result.
Yeah, and you mentioned an HPC example, but you could imagine any type of cluster. I mean, for example, a coiled cluster, you could imagine you could do something. Something
yeah,
similar.
you would think of a coiled cluster. Yes, you can put it into the coiled cluster. In fact, I have not used HPC clusters in quite some time, but I've used the equivalent of coiled clusters much more often nowadays.
For sure. We've got a question. Someone just joined. Does Datashader work on other types of data besides GIS data?
Yes, I'll show a variety of data types. In fact, just a couple of more down in here. So I'm starting with this because it's interpretable by humans. So first, let's finish with this example, and then we'll get to one that's not GIS. Datashader has nothing to do with GIS, has no knowledge of coordinates or projections or anything about that's specific to the Earth. It's
also, I just want to give a shout out to all like the cool Bokeh widgets and stuff that happen out of the box, essentially.
Well, not out of the box. These were, that's another thing too. We worked
from
hard.
a user perspective, right?
Yeah, from the user perspective, they came for free. They did not come for free. When Peter gave his talk in 2016, literally none of this worked.
Yep.
Nothing left or right worked. None of it worked. You could display the image, but that's what you could do at the time.
Yeah.
And so what's in particular, like if you wanted to, this will pretty much illustrate what it is that Datashader is doing. As you zoom in here, Bokeh is interactively realizing, oh, I have a new viewport. It sends that viewport saying this latitude and longitude range, sends that to Datashader. Datashader re-renders into an array, passes that to Bokeh. Now what Bokeh does is to do the color mapping, and so that it can update this color bar. It's the client side controlling this rendering. This is all recent stuff. Bokeh couldn't do this with Datashader data until quite recently. So what that allows you to do is to have pretty flexible interactions. Like you can go ahead and find out that there were 54 earthquake events in that pixel. It's like, oh, okay, maybe I want to zoom in there and see what those 54 points are. And now it's zoomed in, so now there'll be fewer. And you can keep zooming in, and you have the automatically updating color bar. You've got the hover to show all of that. And so what we've done is integrate with Bokeh so that Bokeh can handle the stuff that the user, that is speaking to the user, and the numbers are still crunched remotely on the cluster on the server.
Awesome. Yeah, that reactivity is really nice. And also, thank you for opening with examples that aren't a taxi data set example.
Oh, I don't think I have the taxi on here. I could do it. That would have been our first example of text to data. All right, so let's leave Geo Data behind, even though it's the same data set. Let's plot some things on it that are not to do with Geo, and just kind of make some points about why you would want to do this. And we'll get back to some other features above. So here, all I did is the same plot I did a minute ago, the same call. All I did is change X and Y. So I looked at what columns were available, and I literally randomly said, hey, what the magnitude of the earthquake might be interesting to examine with respect to the depth of the earthquake. Sure. I have nothing about earthquakes. I thought that might be interesting. And so I plotted it, and immediately you see all sorts of interesting stuff. Now, I don't know whether they're scientifically meaningful, but I do see that there's stuff going on. You see that there is some sort of correlation. We could probably put an R number on that. It's not great, but it's there's some sort of correlation there a little bit. And there's also all these other patterns here. And for instance, you can see immediately at what level the data has been discretized. You see these little grids here. I'm sure that the depth does not occur in discrete things in the real world, but it does when it's being reported. And it also clearly is being reported in ways that kind of, if I scroll this out, you'll probably see that better, that match, they've been rounded to nearest guesses. So 10 occurs more often than 10.2 and 9.8 and so on. And so you can really see some of the patterns that human beings have put on this data as they, or maybe some automatic processing or whatever. Yeah. There's little bits every so often corresponding to regular intervals. There's an overall discretization. Clearly, at some point this was a CSV and it had a certain number of digits. I can determine that from this plot immediately, just by looking at this plot and seeing these patterns. Immediately I can see, oh, okay, this is maybe not the full precision that you might have had. And I can see that like in a quarter of a second just by seeing these weird patterns. And then you can see other things that are, who knows how meaningful they are, just about the actual distribution of, like, are any of these scientifically important? Probably not. They're almost certainly data collection issues is my guess. You can't tell, you're just seeing your raw data. Like, is there the depth of -3? I don't even know what that means. I guess that's an earthquake in the air on a mountain, I suppose. Anyway, that's
you make it look so easy, and of course, Datashader makes it look so easy, but it's highly non-trivial to do. Essentially, what you're doing is exploratory data analysis with really large data sets without having to write a lot of code and that type of stuff out of the box, which is darn exciting.
Yeah, just start with some. Everyone can get a hold of a data frame, right? And literally, I just called them out. I'll call out another one. I don't know. Well, a lot of these are not going to be numeric, so they're not going to work very well. So I actually don't know which one is numeric. I did another one here. Okay, here's depth versus latitude. Now, why would that matter? The latitude, as you're going up the latitude around the top of the Earth, the depth of the earthquake, would that change? Well, it has the same problem here of people report round numbers for the data. It's about 200. It's about 400. Those, you can really see those going up there. We also see a lot of other structure here. Again, literally, I have no idea what any of that means. I'm just plotting it and you can see. And if you were to subsample this data, like if you did, you get 10,000 of them, frac. If you were to take this data and try to plot it without rasterizing it, I hope 1% was enough to make my computer not crash. Okay, this is the data without rasterizing. The advantage there is you can actually hover over individual data points, and here you can see the depth and latitude, but you could have seen all the other columns. Yeah. But pretty much it's an overplotted mess.
Yep.
You can see some things here. You have no idea that, you don't realize that people are putting in round numbers. You don't see any of this structure over here. It's just like, it's a mess. And the thing is, you can totally make a much better plot than this with standard plotting tools, but you have to use a lot of domain knowledge. You have to really understand, oh, Well, in this case, we're going to use small dots. We're going to use transparency. We're going to subsample to this. We're going to filter it this way. You're going to do like 50 processing steps before you get to this. With Datashader, there literally aren't any parameters that you need to tune. There just aren't. There are parameters you can tune, and there are totally different things you can use Datashader to show, but you don't have to. You just dump it. And that's a good point for here. Right now, we're using adaptive color equalization, which I strongly recommend you do from the start. So if we were to change this to linear, linear would be the default for a plotting program. In this case, it actually is not doing too badly, but linear is basically mapping the count of earthquake events from 0 here to the highest number, which is looks like 9,000 linearly. And so you can easily see what the highest numbers are somewhere in there. And often linear works, but it works well with your data is linearly distributed. Log works well if your data is distributed well on a log. Well, that one probably is more appropriate for this distribution. Or you just don't care. You just write EQ hist. It does histogram equalization on the color bar so that it maximally uses your available dynamic range and then lets you figure out what it means. Basically, EQ hist is give me a plot.
And it's reactive when you zoom in, right?
That's right. And so it'll continually be updated depending on whatever it is you're showing. And you notice it's a mess. Like this is from 1 to 2, and then 2 to 3, 3 to 4, 9, and 9 to 248. It's like just because these high events are much more rare. So it's hopefully that makes sense. If not, read the Datashader website. It goes on in excruciating detail why you want to use EQ hist and how to interpret it, and that it's important.
It made perfect sense to me. Thanks, Jim.
All right, so that's it for the basic demo of what Datashader can, how Datashader works, and then the rest is just illustrations of how you can use Datashader to see cool things and understand new different types of data. So the rest I'll just sort of page through. So it's a good time to stop if there are any fundamental questions. I should deal with them now.
Everyone's loving it, and we're on track. So I'll just let you know we've got around 20 minutes left. So whatever you think the most fun we can have in that 20 minutes.
All right. Okay, here's something maybe not fun, but just at least totally different. Here we're using Datashader to render polygons. This is not the taxi data set. This is building data set. So this is every building in New York City. And so notice how it's all blocky until we move in. It's going to do its usual job of it waits, it churns, and then it re-renders, and then that's what it displays. So when you're zoomed out, everything is kind of a jumble. But if you zoom in, you can actually start to see boundaries between buildings. This is, buildings tend not to overlap with each other, so you don't need any of Datashader's fancy ways of stacking data and telling you what's overlapping each other, but you do need to be able to handle a lot of data points. And in this particular one, we're using Datashader together with Bokeh to do some kind of cool stuff, which is, remember, Datashader is turning it into an array and rendering that on screen so your eyeballs can see it. But what if you wanted to know what this thing here is? Well, it turns out that's the United Nations South Annex building. And how that's working is we're tightly integrating with Bokeh in this example. So we're rendering the Datashader image. And then when you hover, it does a query on the original data set in that location using a spatial index. It said, hey, what is over there? All I'm showing are pixels, but let's query the original data set to recover the original data that was used to generate those pixels and then overlay that. And so if you just hover around, you'll see that it is able to pull in the original thing that is being rendered by Datashader, overlay that on top, and then tell you about it. So this is a really useful thing with Datashader, because Datashader by itself gives you a beautiful picture, but then you're on your own to figure it out. But if you pair it with Bokeh in this way, this is using a new facility in HoloViews that my colleague John Stevens presented at Sci-Fi this year. Title of the talk is like Needles in the Haystack, so that you can see the entire haystack. But you can also find out every individual little thing that you can see. Whenever you see something interesting, you can figure out what it is.
That's important to go and check out all the Sci-Fi talks if you weren't able to make it to the conference when they're when they're online as well. We have a quick question from Simon Thor, who's watching from Sweden. And this, I think, speaks to the previous example. Simon's wondering, how can Datashader do the rasterizing so quickly? He asked, does it rely on the back end, for example, Dask for that computation?
Yeah, pretty much. The rasterizing is done in a very tightly optimized inner loop of Numba code. And so that if we're using Dask, that same Numba code is being executed in parallel across multiple CPUs or across the cores of a GPU. In this particular case, looking where I ran this machine doesn't have a GPU, and it's just normal Linux box with a few cores. And so I believe that would work fine without Dask, just using Numba to parallelize across the cores. But really what makes it fast is Numba fundamentally. The first thing to do when anything is make your sequential performance really good. And then if that's not enough, use Dask and distribute it. But if you can get 100 times speed up on a single core, then do that. First do that. It's a lot more practical. And that's what this does. These are all heavily optimized on single core, which means that if you have 10 cores, then great, but it's still pretty fast.
Yeah, and it's probably worth mentioning, this is something you and I chatted about before we went live as well, right? And something Matt Rockland talks about, and you mentioned maybe he tweeted this out recently, that before you use Dask, try some other things. Distributed computation comes with overheads. So firstly, if you can optimize your pandas code, try that first. Secondly, if something like Numba can help you, definitely try that as well. And if you really need to use distributed compute, jump in. And Dask, of course, is known to be the best solution for that.
Clearly the only way. Certainly the only way I would consider. There are some people in the world who would try some other approach, but I don't want to hear about it.
Definitely not. And they're not welcome on this live. No, I'm kidding.
No, there might be some useful interactions with others. Anyway, it doesn't matter.
No, that's absolutely right.
All right,
Awesome.
So carrying on, we've got other types of data. This is airplane flight trajectories. And these are just highlighting what certain airports in certain cities look like when you zoom in. And in this case, you can see that if you're flying over London, you spend a lot of time just circling. So it's if you were to try to plot this with a regular plotting program, you'd see, oh yeah, there's dense stuff over London, yeah. But with Datashader, you can zoom in and you can see exactly what's happening at every point.
And did you make these ones? These are beautiful, Jim.
I did not make these. My colleague Philip Rudiger made this one.
Cool.
And this is publicly accessible data, but you have to do a lot of work to get it because they try not to just dump it out on the public. So you have to sit and collect data for a while as it's being published to have enough of these flight trajectories.
Okay.
And if you zoom in, you see a lot. But anyway, yeah, that's Philip. This is similar, but this is boat trajectories, and this is illustrating. This is, of course, the United States, and it's colored by the type of boat it is. And these are recorded by various receivers that are on the coast. And so there's no data once it's far enough out, unless once you get down to Hawaii. But so it's primarily coastal data, but it's otherwise similar to the taxi data you mentioned, but it's much more interesting because it's boats. And so if you zoom in there, it kind of illustrates something from Datashader, which is that if you colorize data by the type of, by some category, you can also often see that things that look like they're just a big jumble are not a big jumble. If you have to figure out what the right categories are to do this. Here, all I did is figure, you've got some 100 categories. I took the 6 most common categories, 6 most common, and then dumped everything else into unknown, or other. Sorry, I dumped everything else into other. And so I took the 6 most common categories, and then I colored by the category because I had a hunch that I bet different ships behave differently. Like if it's a cargo vessel compared to a fishing vessel, do they behave differently? And the answer is, oh my God, 100% they behave differently. And so this, if you can use Datashader to not just to render all the data points, but to see how those data points relate to some other quantity of interest or some other category of interest. In this case, like fishing vessels, a cargo vessel tends to go in a straight line and go far away. They just go straight to where they're going. A fishing vessel leaves a port and then goes around for a while and does some stuff and comes back. In here, somewhere in here, there are, this is a passenger vessel. Well, that's clearly going to be some sort of ferry that crosses the way, and the cargo vessels go along the waterway. The ferry crosses the waterway, and so I can use my knowledge of the world to make sense of these. But really, the reason it looks pretty is that it's revealing the structure that's already there. I'm just using my knowledge to explain the structure. The Datashader is showing you the structure. It shows that the category is deeply and tightly related to the behavior in terms of pixels. And then this is also illustrating Jean-Luc's point about hover. And so this particular, if you click anywhere, it'll do a spatial query just as for those building data sets, do a spatial query in that area. In this case, it takes the top two, because it says max hits 2. It takes the top 2 and then shows you what actual vessels those were, and then actually queries to find out a picture of those vessels. And so if I click around, these particular ones are red because they're cargo vessels, so they look like that. And if I click on the fishing vessels down here in this green area, I guess, well, there's a fishing vessel, I guess. I mean, it's certainly a smaller vessel. It's probably fishing. Let's see. Yeah, that one's fishing. So, and so on. So you can really, using this new integration with Bokeh and inspection, you can see things that are pretty. And why are they pretty? They're pretty because they're revealing a lot of structure that's there. And then you can use these interactive things to understand that structure.
That's awesome. And I'm wondering, I can't, we talked about this before. I can't recall whether you mentioned it now. Where's the server running for this?
This particular one happens to be a AWS, or maybe it's a DigitalOcean server. It's not anything special. This particular one would run faster on my laptop, but then if I try to run all the demos on my laptop, I'll run out of memory. So I prefer to leave them just running in the cloud somewhere. But this is one of the ones that's accessible from, if you go to examples.5is.org and click on ship traffic, that is all I did. So I'm literally just showing you the result of clicking on ship traffic.
Awesome. So the fact that it's running somewhere else raises a question that I think some people will have. I mean, it can be notoriously frustrating to get up and running on the cloud. How straightforward is it to get examples like this up and running on an external server and then?
He did not, I did not pay him to say that, but it's actually running on one of our products from Anaconda called Anaconda Enterprise that handles spawning a service for us. And so we use that because it's convenient and because it's free to us. So basically what we would do is write a little YAML file. This is all explained at examples.pybits.org. So if you want to add a new example, the way you do it is you write a little YAML file that says the environment you want. You write the command that you want it to launch. In this case, it'd be panel serve dashboard, ship traffic dashboard.ipynb. And then everything else is handled by our product. We can also, you can go to a command called Anaconda project. That's what handles all of this. And you can use that to create a Docker container. And if you've got that, as long as you've got any place you can put a Docker container, that will wrap up any one of these examples in a self-contained portable thing that just sits there, and you turn on the Docker container and it starts a web server with this thing in it and nothing else. So
awesome.
That part works well and is easy.
And I'll reiterate that Jim did definitely not pay me to say that. Having said that, where I was going was maybe you could try it on Coiled Cloud as well. Not that Coiled Cloud is competitive with Anaconda Enterprise in any way, but these are two different ways to think
about
it.
Very different approaches. Anaconda Enterprise is primarily meant for on-prem work where people would love to have cloud, but they're clamped down and they're not allowed to have any cloud stuff. So you sort of recreate a cloud inside your own system, and that's essentially what we've done, and then we went ahead and made it public. But that's not really what I'd recommend an ordinary data scientist to do. That's something for your IT to do, but not for you to do. So for you, if you're just trying to get access to compute resources, Coiled, it was a much more practical approach for that. So
and I did not pay Jim to say that either.
Fair enough. Yeah.
Awesome. So we've got around 10 minutes left. Let's. This is so much fun, man. Let's see what else you want to show us.
What else we got here? So this one I won't linger on. I just want to point out that Datashader can datashade anything. In this case, it's datashading stock selling events. So some transfer of this particular data is each time a stock is bought or sold at a particular timestamp, it makes a line, and if there are many of them, there'll be many overlapping lines. And in this case, if you zoom out, it's a data shaded plot where it's just showing you where there might be interesting stuff to zoom into. But then if you zoom in enough, it will eventually become a regular bokeh plot that you can hover over. And so this is another sort of response to, yeah, that's a pretty picture, but how do I understand what's happening in that picture? This is a slightly different code path, a different example, but kind of illustrates that. And then, okay, 2 more points. One, I'll come back to this point. One is that I've been showing bokeh-based interactivity. Now, people have gotten jealous of that, of course, and so now there is Plotly-based Datashader interactivity. There's a Medium article about that. You just search on Medium for Plotly HoloViews, and it shows you how to use HoloViews, which is behind a lot of the plots you'll see. I didn't really talk about that. And Datashader in Plotly and in Plotly Dash, and works quite well there. It's a good match to it. And then there's also, in the most recent Datashader release, we have now support for Matplotlib, a direct Matplotlib artist, and that we ship this new command called dsshow, which returns a Matplotlib artist using an API very similar to what you've already seen. So you can choose your color mapping, you can choose what you want to map on X and Y and so on. And then, okay, well, yeah, one more little thing. I did not do this, but it's just one of my favorite blog posts I've ever read. It just appeared in on a web search one day. Instacart. We have
that is a great name.
Yeah, space, time, and groceries. I don't know who this is. Obviously, he's very competent and discerning in his tool choices because he's selected Datashader to look at Instacart data. And they do all sorts of cool things. They are looking inside the store to optimize the patterns of shoppers as they go through the aisles. And they're doing some really good analysis to get rid of the bogus GPS data set, GPS readings. But just to show some of the Datashader results, like these are pretty much all Datashader. So they're using it to figure out which ones are accurate. The accurate ones in blue and the red ones are a mess. So they can easily tell that. And then they can plot based on the speed of the shopper. So basically, as they took a freeway to get there, they're very fast, and as they get closer, they get slower. And then color them by which store they were going to. Figure out, color it by what the shopper is doing inside the store. Like they're clearly have stared a lot at this data, and presumably it's helping them build an app that tells the shopper where to go in the store next and not waste any time, and come out of the store quicker. I'm guessing that's what they're doing with it. All right, and then the last bit is just to point out that the best way to use any of this is kind of like what the Instacart folks were doing, is they're taking data that means a lot to them and that they care about, and deeply diving into it using Datashader. And that's what I would recommend everybody does. If you've got something that really speaks to you in some area of science, this is something that speaks to me just because of somebody concerned about issues of social justice and so on. This is a plot of the US Census from 2010. It's one of our earliest examples that Peter probably would have given in his first talk. And since then, it's been embedded nicely in Bokeh and can do all sorts of cool stuff with it. But it's basically the same data. And if you take that data and you zoom in, it's colored by the reported race of the person as they reported to the census. And if you look at all of the US, you can see that that most of the US is, there are a lot of white folks in the US. There are other here would be Native American. So these are Native American reservations here in the American West. And if you zoom in where I am right now, where I'm sitting, it's around here. I'm in Austin, Texas, and it'll update as I do that. You can see I'm in Austin. This is now a familiar, it's Lake Travis. And this is Austin downtown here. Go zoom in enough. This is downtown, and so if you notice that downtown, people mostly don't live anywhere, but where they do live, they live in little dense clusters in the townhome sky rises and whatever. And then I'm let's see, where am I? Nobody lives in UT campus for the most part. What am I doing here? Unfortunately, I don't have the labels on here, so I have to figure out where I am. Okay, this is I-35 then. All right, so I'm in this neighborhood right here. And I can see that if I look in my neighborhood, I can see I happen to be at this neighborhood today, and then I can see various little spots that indicate people in the census. Now this is data from 10 years ago, but then if I zoom out, that I can see that I'm in a very wide area. And over here on the east side of Austin, there are Black areas and there are Hispanic areas, and then there are also very different densities. The Hispanic areas here tend to be high density compared to the white areas. And that's indicating a lot of people living per square mile compared to the other areas. And I can look at this and I can correlate between what I see here and what I see in the neighborhood and go back and forth. I know this data on the ground, literally, and I can go back and forth, and it just blows my mind all the time to look at this and think, oh, yes, this is real. This is Datashader revealing to me what I already know. And then I can use the same thing to explore a city I haven't been to and realize a whole lot about that city. And it just blows my mind all the time how easy it is to just use. If you've got access to the raw data, you can see a lot about what human beings have been up to. Oh my God. That's awesome. My meta message.
Yeah, that's beautiful. And as you made clear, if people want to get involved, see if there's data sets that they're interested in that they can render using, they can check out using Datashader and all the associated tools you've introduced today. I think the other thing to clarify once again is that the reactivity is wonderful, right? That you can zoom in and see more of the data reveal itself with limited code is incredible functionality.
That's right, and it's important that it doesn't need code, because anything you do to slow down that process will stop you from exploring and discovering the thing you didn't know was there.
Yeah,
so it's really, don't put any code in the way and don't put any parameters in the way. Just reveal it and let me deal with it.
Yeah, absolutely. Is there any other ways that people could get involved? I've shared the links to datashader.org, examples.pyviz.org, and holoviz.org.
So each of our sites in HoloViz will have a Discourse link on them. The first thing to do is, if you make something great, put it on Twitter, because I just love seeing those things and other people can see, because everyone's working in their own field. You might not realize there are many fields that have never heard of Datashader. They would have no idea. And then somebody might see that picture and say, my data on X and my data on Y. All right, that's cool. I should try this out. So if you tweet it in your field to your followers, that is super helpful, because you can probably change somebody's life. They could explore and understand data in a way that they couldn't before. So first off, Twitter, and if you actually want to talk to us and the other Datashader users, there's Discourse. And then if in terms of actually helping out with the project, what we always need is documentation and examples and typo fixes and reports that links don't work and all this stuff. We cannot keep up. We just generate so much stuff, we cannot keep up with it. And so we really need people out there to catch us when we make missteps. So that's the immediate way to get it started. And once you do that, you're going to get roped into doing more and more on the project eventually.
And is there an issue tracker or open or website which has issues tagged for beginners or?
Datashader tends to have relatively few for beginners, and I would recommend starting with HVplot to use Datashader, and then HVplot has things for a good first issue and such. Datashader, the bulk of there are some things around the edge of Datashader that are super easy to do, but the core of it, you have to learn Dask. You have to learn multi-dispatch, you have to learn Numba. Yep. You pretty much have to test, did it break GPUs? That makes it hard to address the core of Datashader. But the good news is nobody else does either. Everybody just uses Datashader and they build the things around it. So
yeah, right.
You probably won't need to mess with it. I don't mess with it very often. In fact, I have to go find somebody to work on it when I need something in the inner core, the stuff Jim Chris wrote originally. I don't touch it. I do all the stuff around it.
For sure. All right, well, that's a wealth of resources for people to check out and further stuff to do. Thank you so much for joining today, Jim. It's been an absolute pleasure.
Great. Thanks for having me. It's been fun.